because of all of you, India has been really popular in the world's endless and the tireless and the selfless efforts of the teachers that we all achieve our goals.
And the next award is for the Best Coaching Institute for Boards and Entrance Exams in Maharashtra. And it goes to one and only Sinhal classes. With a big round of applause, please welcome Managing Director Mr. Sudhanshu Sinhal from Sinhal classes to kindly come on stage and receive the award. A big round of applause, everybody, all together. Come on, make it louder. Sinhal classes was founded in 1981 under the expert guidance of
गुड मॉर्निंग स्टूडेंट्स। आज का हमारा टॉपिक इज़ मोल कॉन्सेप्ट। ये 11th का सबसे पहला टॉपिक है, सबसे बेसिक है, बहुत ज़्यादा मुश्किल नहीं है। बट हाँ, अगर इसके कॉन्सेप्ट्स आपको अच्छे से समझ में आ जाएंगे तो आगे केमिस्ट्री में बहुत ज़्यादा प्रॉब्लम्स आपको फेस नहीं करनी पड़ेंगी। सो यू नीड टू पे अटेंशन टू दिस चैप्टर। तो सबसे पहले इसको कैटेगराइज करते हैं। हमारा सबसे पहला टॉपिक जो मोल कॉन्सेप्ट में रहेगा, दैट विल बी लॉ ऑफ केमिकल कॉम्बिनेशन। जो केमिकल्स होते हैं, जो हमारे एलिमेंट्स, मॉलिक्यूल्स, ये सब होते हैं, ये कैसे कंबाइन करते हैं, इसके कुछ बेसिक लॉज हैं जो हमें काफ़ी हेल्प करते हैं आगे केमिस्ट्री में। तो वो लॉज हमें पहले पढ़ने हैं। तो उन लॉज में जो 4 लॉज हैं, नंबर 1 इज़ लॉ ऑफ कंजर्वेशन ऑफ मास। इसको कुछ बुक्स में लॉ ऑफ मास कंजर्वेशन भी बोलते हैं। सेकेंड इज लॉ ऑफ कांस्टेंट प्रोपोर्शन और डेफिनेट प्रोपोर्शन। ये दोनों सेम ही चीज़ के 2 अलग अलग नाम हैं। देन नंबर 3 law of multiple proportion and then number 4 law of reciprocal proportion। तो आज के लेक्चर में हम इन चारों लॉज को बहुत डिटेल में पढ़ने वाले हैं और इसके बेस पे IIT से रिलेटेड और बहुत सारे एग्जाम से रिलेटेड जो भी क्वेश्चंस आते हैं, हम वो उन क्वेश्चंस को भी आज यहीं पे सॉल्व करेंगे। तो लेट्स स्टार्ट विद द फर्स्ट लॉ, लॉ ऑफ कंजर्वेशन ऑफ मास। लॉ ऑफ मास कंजर्वेशन काफ़ी इंट्यूटिव लॉ है। ये लॉ, इसका नाम सुन के काफ़ी चीज़ें समझ में आ रही हैं। इसका मतलब यह है कंजर्वेशन ऑफ मास, मतलब जो मास है वो कंजर्व्ड रहता है इन एनी पर्टिकुलर रिएक्शन। आप सबको रिएक्शंस का बेसिक आइडिया तो है ही 10th में। तो हर रिएक्शन में एक ऐसा एरो होता है, ये आपको पता है। एरो के लेफ्ट हैंड साइड पे जो चीज़ें होती हैं, मैं उसको रिएक्टेंट्स बोलता हूँ, सब लोग उसको रिएक्टेंट्स बोलते हैं। और एरो के राइट हैंड साइड पे जो होता है उसको हम लोग प्रोडक्ट्स बोलते हैं। ठीक है, तो लेफ्ट में रिएक्टेंट्स, राइट में प्रोडक्ट्स, ये हम सबको पता है। और ये रिएक्शन किसी ना किसी कंटेनर में किसी जगह पे हो रही है। तो लॉ ऑफ कंजर्वेशन ऑफ मास क्या बोल रहा है कि अगर कोई रिएक्शन है जो कि एक क्लोज्ड कंटेनर में हो रही है, वो क्लोज्ड कंटेनर क्यों इंपॉर्टेंट है? क्लोज्ड कंटेनर का होना जरूरी इसलिए है क्योंकि प्रोडक्ट्स में हो सकता है गैसेस बन रही हो, और अगर कंटेनर क्लोज नहीं होगा तो वो गैसेस बाहर एटमॉस्फेयर में चली जाएंगी। तो मैं नहीं चाहता कि कोई भी चीज़ एटमॉस्फेयर के में जाए। तो अगर एक क्लोज्ड कंटेनर के अंदर एक रिएक्शन होती है जिसमें मल्टीपल रिएक्टेंट्स हो सकते हैं, 2, 3, 4, एनी नंबर ऑफ रिएक्टेंट्स, तो रिएक्शन शुरू होने से पहले आपने इस कंटेनर में अगर टोटल 100 ग्राम चीज़ें डाली और फिर उसकी रिएक्शन शुरू हो गई, एंड आफ्टर सम टाइम यू कम एंड यू सी दैट द रिएक्शन इज ओवर, बट उसके ख़त्म होने के बाद भी कंटेनर के अंदर आपको जो टोटल वेट मिलेगा वो 100 ग्राम्स ही मिलेगा. सो दिस लॉ टेल्स मी कि रिएक्शन शुरू होने से पहले और रिएक्शन शुरू होने के बाद इसके अंदर के जो भी कंटेंट्स हैं उनका टोटल एडिशन अगर मैं करूं, मास का एडिशन, सो दैट इज कंजर्व्ड. दैट मीन्स मास इज कंजर्व्ड. अगर आपने शुरू में 100 ग्राम लिया तो 100 का ना वो कम होगा ना वो ज़्यादा होगा, वो 100 सा 100 ही रहेगा. तो इसको हम कैसे अप्लाई करते हैं? लेट्स टेक एन एग्जांपल. लेट्स सपोज मैं हाइड्रोजन और ऑक्सीजन की रिएक्शन को ले रहा हूँ. तो हाइड्रोजन और ऑक्सीजन की रिएक्शन से H2O बनता है. आप सबको बैलेंसिंग का कुछ आइडिया है, 10th क्लास में बैलेंसिंग सिखाई जाती है. बैलेंसिंग एक्चुअली लॉ ऑफ मास कंजर्वेशन का ही दूसरा रूप है. कैसे हम लोग बैलेंसिंग कैसे करते हैं? हम लोग अक्सर ये देखते हैं कि इधर 2 हाइड्रोजन है तो उधर भी 2 हाइड्रोजन होने चाहिए, इधर 2 ऑक्सीजन है पर उधर एक ही ऑक्सीजन है. तो लेट्स डू इट लाइक दिस. हमने यहाँ पे 2 लगा दिया तो यहाँ पे ऑक्सीजन 2 हो गए, तो ऑक्सीजन तो बैलेंस हो गए, बट हाइड्रोजन इम्बैलेंस हो गया. हाइड्रोजन 2 × 2 4 हो गया. तो हाइड्रोजन को बैलेंस करने के लिए मैंने यहाँ पे 2 लगा दिया. ये बहुत ही सिंपल रिएक्शन है, सब लोगों ने 10th में देखी होती है. बट ये जो बैलेंसिंग है ये करते वक्त आपने एक्चुअली लॉ ऑफ मास कंजर्वेशन ही लगाया है. हाइड्रोजन उस तरफ कितने हैं? 4 एटम्स, दैट इज 4 ग्राम्स. हाइड्रोजन इस तरफ कितने हैं? 4 ग्राम्स. ऑक्सीजन उधर कितने हैं? 2 एटम्स ऑफ ऑक्सीजन. 1 एटम ऑफ ऑक्सीजन is 16 ग्राम्स, सो 16 × 2 is 32. यहाँ पे कितने? यहाँ पे O2 का एक मॉलिक्यूल है, उसका वेट कितना? 32. तो इफेक्टिवली इस एरो के लेफ्ट में टोटल वेट हम चेक करते हैं और इस एरो के राइट में हम टोटल वेट चेक करते हैं. तो यहाँ पे हाइड्रोजन का वेट है 4 ग्राम्स, ऑक्सीजन का वेट है 32 ग्राम्स. ठीक है. और वहाँ पे H2O का वेट होता है 18. हाइड्रोजन इज 1, 1 × 2 is 2, 2 + 16 is 18. तो 18 × 2 दैट इज 36. तो बहुत इजीली हम लोग देख सकते हैं दैट 4 + 32 is equal to 36. तो एरो के लेफ्ट में और एरो के राइट में जितना भी टोटल मास होगा वो कंजर्व रहेगा. इसी को बोलते हैं लॉ ऑफ मास कंजर्वेशन. तो आई होप ये टॉपिक आपको समझ में आ गया होगा. हम थोड़ी देर में इसके ऊपर जो क्वेश्चंस आते हैं जिस तरीके के, वो क्वेश्चंस भी डिस्कस करना शुरू करेंगे. बाकी ये टॉपिक बहुत ही सिंपल सा टॉपिक है. देन नाउ लेट्स डू सेकंड लॉ, द लॉ ऑफ कांस्टेंट प्रोपोर्शन. लॉ ऑफ कांस्टेंट प्रोपोर्शन. नाउ इस लॉ का डेफिनेशन बेसिकली अगेन यहाँ पे 2 वर्ड्स आ रहे हैं. वन इज कांस्टेंट, अनदर इज प्रोपोर्शन. सो बेसिकली ये लॉ मुझे ये बताता है कि अगर किसी भी कंपाउंड की हम बात करें, लेट्स टेक एनी कंपाउंड, लेट्स टेक अमोनिया NH3. NH3 को बनाने के हमारे पास बहुत सारे तरीके हैं. ठीक है. अमोनिया को आप इंडस्ट्रियली प्रिपेयर कर सकते हो, अमोनिया नेचुरली भी मिलता है. बहुत सारे तरीकों से मैं अमोनिया बना सकता हूँ. बट एवरी टाइम अगर आप किसी भी मेथड से भी अमोनिया बनाओ तो हर केस में नाइट्रोजन और हाइड्रोजन के एटम्स का रेशो विल ऑलवेज बी 1:3. सो द पॉइंट इज अमोनिया कैसे भी बना है उससे फर्क नहीं पड़ता है. नाइट्रोजन का एक ही एटम रहेगा, हाइड्रोजन के 3 एटम रहेंगे. सो नाउ दिस इज कॉल्ड एज लॉ ऑफ कांस्टेंट प्रोपोर्शन. प्रोपोर्शंस, रेशियो, द रेशियो ऑफ 2 एटम्स in a particular compound will always be same irrespective of how you prepare it. This is the definition that I have just told you. बाकी definitions के लिए you need to refer the book. Proper definitions को याद करना is very important. मैं एक बार वापस से definition बताता हूँ. The ratio of different atoms in a particular compound remains the same irrespective of the method of preparation. तो अमोनिया को बनाने के हमारे पास बहुत सारे तरीके हो सकते हैं. ठीक है, बट उस तरीके को जानने की ज़रूरत नहीं है। अगर मुझे ये पता है कि ये अमोनिया की बात हो रही है तो अमोनिया विल ऑलवेज भी NH3, प्रिपरेशन कैसे भी हो। सिमिलरली अगर मैं पानी की बात करूँ, वाटर, तो वाटर को प्रिपेयर करने के बहुत सारे तरीके हो सकते हैं। मैं किसी भी कंपाउंड की बात करूँ, एक कंपाउंड को प्रिपेयर करने के मल्टीपल वेज हो सकते हैं, बट अगर उस कंपाउंड का फॉर्मूला आप लिख रहे हो तो दैट मीन्स आपको ये पता है कि वाटर के अंदर हाइड्रोजन एंड ऑक्सीजन का रेशो, हाइड्रोजन अपॉन ऑक्सीजन का जो रेशो है, एटम्स का रेशो, दैट विल बी 2:1। ये एटम्स का रेशो है। और इंपॉर्टेंट बात ये कि एटम्स का रेशो अगर सेम है तो मासेस का रेशो भी कहीं ना कहीं सेम होगा। लेट्स सी दिस, नाइट्रोजन का एक एटम है, मतलब इसका वेट है 14, ठीक है। वैसे एटॉमिक मास हम लोग AMU, एक स्पेशल यूनिट होता है, एटॉमिक मास यूनिट, हम उसमें डिफाइन करते हैं, तो आगे की क्लासेस में हम लोग वो भी डिफाइन करेंगे। यू कैन जस्ट टेक इट एज एन एग्जांपल बिकॉज 10th में आपको पता था कि इसका मास 14 होता है। तो नाइट्रोजन के एक एटम का मास है 14, हाइड्रोजन के एक एटम का मास है 1। तो अगर हाइड्रोजन के 3 एटम्स है तो 3 × 1, और नाइट्रोजन का 1 एटम है तो 1 × 14। तो नाइट्रोजन और हाइड्रोजन का वेट का रेशो विल बी 14/3। तो उसके एक एटम का वेट 14 होगा और इसके 3 एटम्स का वेट 3 होगा, तो रेशो 14/3 होगा। और जो टोटल वेट है NH3 का वो कितना होता है, 14 + 3 17। तो मैं हमेशा ये बोल सकता हूँ कि आप कैसे भी अमोनिया बनाओ, पर अगर अमोनिया के 17 ग्राम्स होंगे तो उस 17 ग्राम में 14 ग्राम्स नाइट्रोजन के होंगे और 3 हाइड्रोजन के होंगे। अगर आपने किसी और जगह पे अमोनिया को बनाया और आपने 17 ग्राम्स की जगह एक्चुअली 170 ग्राम्स बनाया, ये आपकी मर्जी है कि आप कितना भी अमोनिया बना सकते हो। तो अगर आपने 170 ग्राम्स अमोनिया बनाया होता तो उस 170 ग्राम में से रेशो अभी भी वही रहता, बट एक्चुअल अमाउंट्स क्या होते हैं, नाइट्रोजन का 140 ग्राम होता और हाइड्रोजन का 30 ग्राम होता। तो अल्टीमेटली 0 से 0 कट जाएगा तो 14/3 का रेशो ही रहेगा। तो लॉ ऑफ कांस्टेंट प्रोपोर्शन मुझे यही बोलता है that irrespective of the method of preparation of any particular compound, the ratios of individual atoms, the ratios of number of atoms, the ratios of masses of atoms remains the same. तो नाम से ही मुझे समझ में आ रहा है that the proportion will remain constant. इसी का दूसरा नाम जो हमने पहले भी बोला था, definite proportion. So the law of definite proportion, law of constant proportion, ये दोनों सेम है। तो आई होप ये लॉ भी आपको समझ में आ गया होगा। हम लोग थोड़ी देर में इसके ऊपर क्वेश्चंस स्टार्ट करेंगे। नाउ थर्ड लॉ इज लॉ ऑफ मल्टीपल प्रोपोर्शन, तो उसको शुरू करते हैं। नाउ इस लॉ की डेफिनेशन समझाने से पहले मैं पहले आपको एक सिचुएशन दिखाता हूँ। उस सिचुएशन में क्या हो रहा है अगर आपको वो समझ में आ जाएगा तो आपको डेफिनेशन भी उसका आराम से समझ में आ जाएगा। इसका डेफिनेशन कुछ इस तरीके से है कि देयर आर 2 एटम्स, ठीक है। लेट्स टेक दोज एटम्स एज कार्बन एंड ऑक्सीजन, ठीक है। देयर आर 2 एटम्स। ये 2 एटम्स ऐसे हैं जो जब आपस में एक दूसरे से कंबाइन होते हैं तो 2 या 2 से ज़्यादा कंपाउंड्स बनते हैं। जैसे ये बहुत ही सिंपल सा एग्जांपल है कि जब कार्बन और ऑक्सीजन आपस में जुड़ते हैं, ऑक्सीजन इन नेचर एग्जिस्ट्स एज O2, कार्बन इन नेचर एग्जिस्ट्स एज कार्बन। तो मैं जहाँ पे ऑक्सीजन लिखूंगा मैं वहाँ पे O2 लिखूंगा। तो कार्बन प्लस ऑक्सीजन जब आपस में मिलते हैं तो CO भी बन सकता है, और कार्बन और ऑक्सीजन जब आपस में मिलते हैं तो CO2 भी बन सकता है, तो कुछ भी बन सकता है। तो ये 2 एलिमेंट्स ऐसे हैं जो आपस में कंबाइन होते हैं और 2 या 2 से ज़्यादा कंपाउंड्स बना सकते हैं। जैसे एक एग्जांपल हाइड्रोजन और ऑक्सीजन का भी हम लोग ले सकते हैं कि जब हाइड्रोजन और ऑक्सीजन आपस में मिलते हैं तो H2O भी बन सकता है, H2O2 भी बन सकता है, ठीक है। तो मल्टीपल कंपाउंड्स बन सकते हैं। तो इस तरीके के एलिमेंट्स के लिए ये लॉ है, लॉ ऑफ मल्टीपल प्रोपोर्शन। तो ये लॉ क्या बोल रहा है, पहली बात तो हम इनको बैलेंस आउट कर लेते हैं। यहाँ पे हाफ लगाना पड़ेगा बिकॉज यहाँ पे ऑक्सीजन एक ही है, ठीक है। तो ये रिएक्शंस बैलेंस हो गई हैं। तो ये लॉ हमें क्या बोल रहा है, ये लॉ ये बोल रहा है कि जब 2 एलिमेंट्स आपस में कंबाइन होते हैं टू फॉर्म 2 और मोर कंपाउंड्स। ठीक है, इसकी डेफिनेशन हम थोड़ी देर बाद वापस से देख लेंगे। तो जब दो एलिमेंट्स आपस में कंबाइन होते हैं टू फॉर्म 2 और मोर कंपाउंड्स, और उन दो एलिमेंट्स में से किसी एक एलिमेंट का अमाउंट आप कांस्टेंट कर देते हैं। कांस्टेंट का मतलब कुछ भी हो सकता है, 1 ग्राम, 10 ग्राम, 100 ग्राम, x ग्राम्स, एनीथिंग। तो मैं क्या कर रहा हूँ, मैं इन दोनों में से कार्बन को कांस्टेंट करता हूँ। ठीक है, तो मैं इसका x ग्राम्स लेता हूँ, तो यहाँ पे भी मुझे x ग्राम लेना है। तो ये लॉ क्या बोल रहा है कि अगर दो एलिमेंट्स आपस में कंबाइन हो रहे हैं टू फॉर्म 2 और मोर कंपाउंड्स, और उन दोनों एलिमेंट्स में से आपने किसी एक एलिमेंट का अमाउंट कांस्टेंट कर दिया, तो जब कोई एक कांस्टेंट होगा तो जो दूसरे वाले एलिमेंट्स हैं O2 का वैल्यू यहाँ पे y होने वाला है और यहाँ पे होने वाला है कुछ z। तो सिंपल सा टर्म है, x grams of carbon in this reaction require y gram of oxygen to give complete reaction। तो इस रिएक्शन में कार्बन के x ग्राम्स के साथ ऑक्सीजन का कितना ग्राम रिएक्ट हो रहा है, y, और नीचे वाली रिएक्शन में कार्बन के x ग्राम के साथ ऑक्सीजन कितना रिएक्ट हो रहा है, z। सो अकॉर्डिंग टू दिस लॉ x कांस्टेंट रखा हमने, तो लॉ क्या बोल रहा है कि ये जो y और z का रेशो है, ये दोनों ऑक्सीजन ही हैं, बट ये दोनों ऑक्सीजन अलग अलग रिएक्शंस में हैं। तो ये जो दोनों ऑक्सीजन का रेशो है, मास रेशो, दिस विल बी अ सिंपल रेशो। सिंपल रेशो मतलब 2/1, 3/1, 1/3, 2/3, इस तरह के सिंपल रेशोज रहेंगे, डेसिमल्स वगैरह नहीं आएंगे। ठीक है, तो अब हम इसको टेस्ट करके देख लेते हैं। इस y और z को मैं भी हटा देता हूँ यहाँ से, और x को भी मैं हटाता हूँ। लेट्स टेक अ रियल नंबर, लेट्स टेक अ प्रॉपर नंबर, लेट्स टेक 1 ग्राम का। तो मैं अब ये देख रहा हूँ कि अगर मुझे कार्बन से
Sinhal classes was founded with the vision to provide concept-oriented learning to the students in standard 9, 10, 11th and 12th science all over Bombay.
What is the story of your institution's brand?
Like I said, Sinhal classes was founded by my father, Professor O.P. Sinhal, and right since 81, our core strength lay in math and science education, and of late, since then we've built upon for our 9th and 10th, the school section courses. We offer all the subjects now in ICSE, CBSE, and some of the state boards as well. Recently, we've undertaken quite a few expansion plans also. So we have acquired a company in Gujarat. We have 14 centers in Gujarat, now 16 centers all over Bombay, all prime locations, easily accessible for the students across Mumbai. And we've also started a satellite division called Sinhal Satellite Learning, which has approximately 15 franchisees all over India now, including Delhi, Kolkata, Nagpur, and many other prominent cities.
What are your growth plans?
Our growth plans are, so Sinhal Classes has been one of the best and the most trusted institutes for 9th and 11th, 12th science, engineering and medical entrance exams, including now in IIT. Our growth plans are to be an absolute national player, providing the best quality education all over India to students all over India. We plan to do that through satellite. A lot of other institutes might have failed because of the lack of availability of really good faculty even in remote locations. With our satellite concept, we can ensure that the absolute best faculty reaches any part of India.
How do you keep your team inspired and motivated?
Okay, that's a tough one. See, we really believe in providing excellent quality of coaching to our students, be that in the form of really good and experienced faculty who've had a lot of coaching experience in other institutes or wherever it might be. It also in the form of really easy to digest notes for the students so they can study or learn the same concepts twice as fast. the way we motivate our staff is by constantly reminding them our aim is not to be the biggest institute in India, but to be the best institute all over India. And that really keeps our staff on their toes to provide the best quality student-centric service to each one of our students.
How do you keep your students inspired and motivated?
So our faculty is not just very experienced, but also very student-friendly. We definitely speak to them a lot about being very approachable for the students. So the students obviously build a very, and most of them are young, quite experienced, about 10 years. So you can say in their 30s. So that the bonding that they share with the students make sure that all our Sinhal students are very inspired and motivated, and even when the times get tough, the professors are always there to help them out.
What is your idea of good education?
My idea of good education, and this is something that is a philosophy shared across Sinhal classes and Sinhal IIT, we strongly believe that concepts are the king. This is a lot has been said about rote learning and in India's education, but right since 81 we've believed in the power of concepts. So and we're starting to see more and more of that. Even Indian education is changing itself towards learning and understanding concepts better. So that's what we train our students in, how to apply concepts, not just mugging up the facts, but how to apply them in real life and also in their exam paper. So that, I believe, is an excellent quality of education that students can have.
Being recognized by Brands Academy for excellence in education, how does it feel?
It feels really wonderful, and I think for coaching classes, as we have been termed, which is not always the most thankful job, because we do get our share of criticism, but I really believe that there is nothing wrong with coaching classes. Great cricketers, great athletes don't get where they get without the help of strong coaches, and that's what we provide to the strongest brain athletes, or the strongest students who really have a very high ambition of what they want to achieve academically. So we are the coaches for them. So it really feels wonderful that Brands Academy has honored us with the Education Excellence Award for the best coaching institute for boards as well as for engineering and medical entrance exams all over Maharashtra. So big thank you to the entire Brands Academy team.
AGP series. AGP. AGP stand for arithmetic, G for geometric progression. Arithmetic geometric progression. Arithmetic progression, it means AP. We know AP is A plus D, A plus 2D, up to A plus n minus 1 into D. GP is R square, R cube, up to R to the power n. Or it might be, I start from R to the power 0, R to the power 1, R to the power 2, and it goes up to R to the power n minus 1, whatever it is. This is AP series and this is GP series. If I want to make a GP series means I have to include AP series as well as GP series. So this will be A into r to the power 0 plus A plus D into r to the power 1, A plus 2D into r square up to A plus n minus 1 into D into r to the power n minus 1. This AP series multiplication with GP series, so this is known as AGP series. First, how to identify what is this series? So I think you know this. This is AGP series. Arithmetico-geometrical series. Now, we can identify the series. Okay, this is the arithmetico-geometrical series. Now, how to solve these type of series? The sequence is something A, R square, and the AP is going on and GP is also going on. Then we have to just solve the series. What to do? See, again write down S and multiplication with the common ratio, that is R. Again writing S multiplying with common ratio R. This is AR. Writing the series starting from one step ahead. AR, A plus D into R square, A plus n minus 1 into D into R to the power n minus 1 plus A plus n minus 1 into D into R to the power n. Now, this is a complete series. This was the series, multiplying the series by common ratio R and starting the series from one step ahead, going like this. If we subtract both the terms, carefully, we can see this is S1 minus R is equals to A plus AR cancel out, AR square cancel out, and all these will be cancel out. This is D common out, R plus R square, R cube up to R to the power n minus 1 minus A plus n minus 1 into D into R to the power n. First term written as it is, A. From the second term, AR will be cancelled out. This D is common, this is R. D is again common, 2D minus D, D is common, again R square, R cube, R to the power n minus 1 minus A plus n minus 1 D into R to the power n. This is the series. Now, this S again can go as S is equals to A plus D, first term R, last term n minus 1. So total number of terms in this case will be n minus 1, first term R. So the GP series is starting with R. So A, that is R to the power n minus 1 upon R minus 1 minus A plus n minus 1 into D into R to the power n. And this whole thing divided by 1 minus R. You have not to remember this formula, you have to remember the process. Because remembering this formula might be possible, you will miss 1-2 term in the way. But if you want to find for infinite series, so this term and this term will be 0. So it's easier to go for the formula. If you want to go for infinity series, this term and all this term will be going for 0. because we know that r lies between -1 to 1 and we are going the power up to infinity, so the value will be very less and goes to 0. So a plus dr upon 1 minus r, whole thing divided by 1 minus r. So for infinite we can write this. So this is the way how to solve the basic question of series. Now, how to convert this into the question? See, s is equals to 1 plus 2x plus 3x square plus 4x cube and so on up to infinity, where mod x less than 1. Find series. Again, we have to just identify the number 1, 2, 3, 4, 5. This is AP, x to the power 0, x to the power 1, x to the power 2. This is GP. So overall, this is given as AGP series, right? In this AGP series, this is given, right? I can rewrite this S into multiply with x as x plus 2x square, 2x into x plus 3x cube and so on up to infinity. So this is the term, and this was given s is equals to 1 plus 2x plus 3x square plus 4x cube, infinite term, right? So see, how to solve. Subtract s 1 minus x is equals to 1 plus x square up to infinity. And you know this is the formula for a upon 1 minus r, and we can find the value of s, the whole square. Simple question, just you have to go with the formula, and with the basic formula we can solve the question different ways. Next, s is equals to 1 plus 3 by 2 plus 5 by 2 square plus 7 by 2 cube up to infinity. So s, so first identify the series, how it's going on. See, this is 1, 3, 5, 7, 9 and so on. AP series. 1 by 2 to the power 0, 1 by 2 to the power 1, 1 by 2 to the power 2, 1 by 2 to the power n, and going to infinity. This is GP series. So one AP series, one GP series product is known as AGP series. Now multiply with common ratio, that is 1 by 2. S by 2 is equals to one term ahead, 1 by 2, 3 by 2 square, 5 by 2 cube and so on, goes up to infinity. Now subtract both this. S minus s by 2 is equals to 1 plus 3 by 2 minus 1 by 2, 2 by 2, 4 by 2 square, this again 2 by 2 square, 2 by 2 cube and going up to infinity. 1 plus 2 common out, a upon 1 minus r. 1 plus twice of 1 by 2 cancel out, 1 plus s is equals to 6. Just you have to start and go for the series and apply the basic formula of this. You get the solution for this, and a simple part, you can say. Now, these are for infinite term. Now for n terms. See, it's given as s is equals to 1 plus 4 by 5 plus 7 by 5 square plus 10 by 5 cube and up to n terms. First thing, what you have to do, you have to find the nth term of this series. AP is 1, 4, 7, 10. So first term A is 1, common difference is 3. So T nth term will be A plus n minus 1 into D. A is 1 plus 3n minus 3, 3n minus 2. This is T nth term. See, this is AP, arithmetic progression. Similarly for GP, it's 5 to the power 0, 1, 5 square, 5 to the power, and so on. First term, R, T nth term, A into 1 by 5 to the power n minus 1, 5 to the power n minus 1. GP series. So AP I am getting nth term this one, and GP I am getting this one. So in the series of AGP, the nth term will be 3n minus 2 upon 5 to the power n minus 1. This T nth term of this series. It means first you have to find nth term of the series. So T nth term, so the T nth term of the series, this one, so I can write this as the up to nth term as plus 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 is 3n minus 2 by 5 to the power n minus 1. Right? This is up to nth term of the series. So s by 5 common ratio into series s, multiply with this one term ahead, 1 by 5, 4 by 5 square, 7 by 5 cube. In place of n, the previous term of this will be 3n minus 5, 5 to the power n minus 1, plus 3n minus 2, 5 to the power n. This when multiply with 1 by 5 and goes up to nth term of the series. Each and every term multiplied. Just you have to be careful for the previous to this term. When you will put in place of n, you will put n minus 1, you will get this term. And the power of 5 is 5 to the power n minus 2, 1 by 5 is multiplied, so this is 5 to the power n minus 1.
heat transfer, which is the next section of heat and thermodynamics. Heat transfer is all about the mechanism by which heat as a form of energy transfers from a region of higher temperature to a region of lesser temperature or cooler temperature. So the fundamental concept or the fundamental idea in heat transfer is very much what we've been discussing all along, in that as at a molecular level, heat as a form of energy is nothing but the kinetic energy of the molecules, be that the vibrational kinetic energy of solid molecules, or be that the translational and rotational kinetic energy of liquid and gaseous molecules. But basically, when we have a region in a material which is at higher temperature, the molecules are basically moving faster, they possess more heat energy, and as it comes in contact with another material or another region of the same material which is at lower temperature, which means that the molecules are in motion with less kinetic energy or with less rapid amount of movement. Naturally, there will be a process whereby the kinetic energy flows from the faster molecules to the slower molecules as a result of collisions, and that is how macroscopically we see that heat as a form of energy is flowing from higher temperature to lower temperature and this process will continue basically till what we call thermal equilibrium is achieved, or the temperature stabilizes. Okay. Now, depending on what kind of material we have, the exact mechanism of this transfer of heat can occur in different ways, and thereby we say that there are various modes of heat conduction. So basically we talk about three types of modes of heat conduction: conduction, convection, and radiation. So as we all know that these are the three different modes or three different methods, you can say, or mechanisms by which heat transfers from higher temperature to lower temperature. So again, coming back to our model of a solid, where the molecules of a solid are basically vibrating about their mean position, but they cannot move about in the sense that their mean positions are fixed. So the more the temperature of a certain region, the faster the vibration, or the more the vibrational kinetic energy. So using that model, we see that when heat transfers within a solid material from a region of higher to lower temperature, at the molecular level it is nothing but the vibrational kinetic energy which is transferring. So that particular mode of heat transfer via the vibrational kinetic energy of molecules which have a fixed mean position, that is called conduction, and thereby we see that conduction is predominant in solids. So and basically at a molecular level it involves transfer of vibrational molecular kinetic energy. Okay. So broadly speaking, this is what happens as a mechanism in heat conduction, and thereby since vibration is predominant in solid molecules, it is the predominant method of heat transfer in solid materials. Okay. Similarly, when we look at our model of a fluid, whether that is a gaseous fluid or a liquid type of fluid, we know that the molecules don't have a fixed position. So they have the tendency to translate about, to constantly move about as a result of their heat energy or the inherent kinetic energy, which is a function of the temperature, of course. So basically a region which we are maintaining at higher temperature, or a region of a fluid which is at higher temperature, the molecules will tend to have more kinetic energy for translation, and vice versa for a cooler region. So again, as a cooler region comes in contact with a warmer region, what happens is instead of directly transferring energy via vibration and collisions, there is basically a sort of current which is set up, okay, of the molecules in the region which is having more kinetic energy or more temperature. They start to naturally, you can say, perforate into regions which have lower temperature, and the molecules are less active, and those molecules start translating into region which is at higher temperature. So as a result, basically what happens is there's transfer of heat energy from higher to lower temperature, and that transfer is happening through the setting up of what we call conduction currents. So conduction currents are possible to set up only in fluids because you need the molecules to move about freely. Okay. So that is why it is convection is predominant in fluids, and at a molecular level it involves heat transfer through what we call convection currents. So physically the molecules which are in a region of higher temperature, through the convection current setup, they displace into regions which are at lower temperature and vice versa, and that is how the heat energy is transferred from lower to higher temperature. So that is about fluids. Okay. Now interestingly, heat can also transfer from one body to another, even if there is physical distance between the two and there is no material medium between the two, which means that there is no possibility of conduction or convection current. But at the same time, a body at higher temperature and a body at lower temperature with a vacuum or space in between them with no physical medium will still manage to transfer heat. And that happens because basically heat can also transfer in the form of a third mechanism which is completely different from the first two. It does not involve any material at all. It is through waves, electromagnetic waves. And as we know that electromagnetic waves are basically non-mechanical waves, so they do not involve any mechanical particles in vibration or translation or any such thing. They are just they are pure form of electromagnetic energy which propagates because of vibrating electric and magnetic fields. So radiation is basically the form of heat transfer that involves electromagnetic waves and propagation of heat through that, and more importantly, it does not involve any sort of physical medium involved. So radiation is transfer through electromagnetic waves. So basically this is where we are looking at heat as a form of energy transferring through something altogether different, through something known as electromagnetic energy, which does not involve kinetic energy of any physical medium particles at all. So very interesting mode of transfer, the third one, radiation, and we will look at it closely. Okay, now, so obviously we'll start with an understanding of conduction here. So as we've already understood, heat conduction being predominant in solids, and at a molecular level the mechanism being transfer of vibrational kinetic energy. Now if we think of a controlled experiment to understand what parameters will determine the amount of heat conduction and the rate of heat conduction, etc., through such a controlled experiment we can learn more about the physical properties of a solid which determine how it will conduct heat. Okay, so let's think of a simple experiment where basically we have, let's say, a metallic cylinder which is isotropic in nature. That means its material properties are consistent throughout. Okay, it has a dimensional length of L and a cross section area of, let us say, A. Now let's say what we are doing is we are insulating the outside part of the metallic cylinder. So we are providing some heat insulation so that there is no exchange of heat between the surface of the metallic cylinder and the surrounding through radiation or convection currents or anything like this. Whereas we are keeping the two cross-sectional areas at the ends open, and let us say those are inside what we call constant temperature paths. Okay, so let's say this is maintained at temperature T1. Okay. So for example, we could keep ice in a insulated box. So basically what will happen is T1 will be 273 Kelvin or 0 degree C. It will be maintained constant at that. Okay. Similarly, the other end is also maintained at a constant temperature. So this is another So for example, this could be steam. So for example, T2 could be 373 Kelvin or 100 degrees C, like this. So just giving an example of how physically we could achieve a constant temperature bath by keeping a large stock of ice over here and continuously passing steam through this insulated box, which would mean that even though heat keeps transferring from this box to this box, or let's say this end A to that end B, but the temperature of this end will be maintained constant and the temperature of this end will be maintained constant because of the physical property of ice. The melting point of ice is 0 degree C. So till all the ice melts over there, the ice will continue to absorb the heat coming in via conduction through the metallic cylinder, but its temperature will not rise till all of it melts. So let's say we have kept a large amount of ice, or we keep supplying fresh ice every now and then. So we make sure that the temperature is maintained at the melting point, which is 0 degrees. Similarly here, in this what is happening is steam is continuously condensing, and as it condenses it gives off heat. But the process of condensation or the process of liquefaction, you can say, of steam happens at the constant temperature, which is the melting point, or sorry, the boiling point, which is 0 degrees C. So that way, even though heat is continuously taken away, but by passing steam continuously, we are making sure that the temperature of that end is maintained at 100 degrees C or whatever T2 is. So if we do an experiment like this, and during the experiment what we do is, we also have a mechanism whereby we can keep measuring the temperature at different points inside the rod or the metallic cylinder, or in this case what we will call the heat conductor. So what we will see, what we will observe from the experimental point of view is that at the start of the experiment, maybe the thermometers at different points start showing some variation with temperature with time. For example, the rod might have had a uniform temperature of 27 or 30, whatever room temperature is to start with, but as we subject it to these two heat or constant temperature baths, the temperature in this region will start to show a rise with time. The temperature in this region will start to show a drop with time. So there will be variation of temperature with time initially, but eventually, provided of course we are maintaining T1 and T2 at constant temperature, so eventually what we will see is that the temperature stabilizes with time. That doesn't mean that the temperature is uniform throughout. It means that the temperature at each point inside the rod stops changing with time, or it reaches what we say steady state value. It becomes steady with time after that. So when that happens, we say that the thermal state in which the rod is, or the thermal conductor is called steady state. And the property of steady state is that the temperature at any point inside the rod has become stable or steady with respect to time. So what we understand here is that, first of all, we understand the definition of steady state. So at steady state, the metallic cylinder, or in this case we call it the heat conductor, achieves a state such that the temperature at any point inside is steady, okay, or invariant with time. That means if we measure the temperature at different points, they'll have different values, okay, but that value will not be changing with time. So when that state is achieved, we say that the conductor is in steady state. Okay. Now, having said that, once that state is achieved, we understand another very important thing is happening, that obviously this being at higher temperature than this, there is a constant rate at which heat is flowing. Now, if you imagine, okay, the conductor